Okay, in this video we're going to take a look at two different, well, technically different theorems about circles and intersecting lines and angles. But these two, in my opinion, are really kind of the same thing. I mean, they're really the same situation. You just have to recognize how similar they are. Now, if you look at these two drawings, you see the one on the left, that angle, and it is important we know some terminology. This angle cuts through the line one way, so this line happens to cut right through that, cuts through the circle with one line, but this line doesn't cut through the circle over here. This is tangent to the circle. We've talked about that term before. That just means it barely touches, barely grazes the circle, and then keeps going on. So it just barely nicks it right there. This one over here, you can see on the right, well, it goes right through the circle with both pieces of the angle. Okay? And that's all right. The mathematical way this functions really is the same for both. Okay, now notice what I have here is an x, okay, on each one of these that represents the angle. Now the x doesn't have to be there. You could figure out any of these things with numbers or variables using these same theorems. So let's take a look at the one to the left first. Okay, notice what I've labeled here, or at least tried to, is the fact that we have two completely different arcs that are intercepted. This angle cuts through, and I've got this big area right here, that big little curved section. That big arc is 130 degrees. Well, there's also a little minor arc that it intercepts, a smaller one, that's only 30 degrees. Now, if I want to find the angle that makes that happen, well, here's the relationship between them. Okay? That angle x is going to be equal to the big arc, 130, subtract the little arc, which is 30, and divide it by 2. Now I can handle that probably in my head. These numbers aren't all that bad. That's going to be 130 minus 30 is 100, divided by 2, which is 50 degrees. And we know what a 50-degree angle looks like. It's just a little more than half of a right angle. So you want to look at this and just say, well, does it pass the eyeball test? That does, yeah, it looks like, I mean, it's a cute angle. It's obviously less than 90. So yeah, our math is probably okay. And my drawings obviously aren't to scale. So I'm just sort of picking some numbers to show you the relationship. They aren't going to be perfect in the drawings. Okay, now that same relationship happens over here on the right. The only difference about this is we don't have a piece of the angle that's tangent to the circle. All we have is the angle cutting right through the circle in two places, but we can still look for the same relationship. This arc right here is 50. And this arc right here is 10, and I'm going to use the same thing I did down here before. That angle is going to be the big arc minus the little arc divided by 2. And in this case, x is going to have to equal 40 divided by 2, which is 20 degrees. Now, that's a really small angle, but we look over here. Hey, that looks like a pretty small angle to make this happen. Yeah, it looks reasonable. Now, the only way this could really behave any differently or have to be analyzed from a different perspective is if, let's say, for example, you look at this one over here on the left. Okay, what if we were told that this angle right here was 50 degrees, but we weren't told this right there? And then all of a sudden we had to find that arc. Okay, all that means then is I know this right here is 50, but now I don't know that one. That's where my x goes. And I'm going to have to do a little bit more algebra or just basic mental math in my head to rearrange this and figure out what number is going to make that possible. So the same relationship applies. We just got to know how to plug the numbers into the right spot. Remember, it's the difference. It's this minus this. Big minus small, cut in half, or divided by 2.